In the previous video, we learned that a qubit is defined by two amplitudes, alpha and beta, and that probabilities are modulus alpha square and modulus beta square. Today, I want to explain why these amplitudes can be complex numbers and how everything connects logically. Our goal in quantum mechanics is simple. When we measure a system, we must get valid probabilities. That means probability must be positive and add up to 1. So P of 0 plus P of 1 equals 1. So whatever math we use, we must respect these rules. So instead of storing probabilities directly, quantum mechanics stores amplitude. So what I mean by that is get C equals alpha and beta. If you want to know more about this notation, you can check out my previous lecture. Okay, so these amplitudes are not probabilities yet. Alpha and beta are the amplitudes of this vector. These are amplitudes. These are not probabilities yet. We have to convert it to probabilities. Okay, we need to convert amplitude to probability. So how do we convert that? We need some kind of function to convert the amplitudes into a valid probabilities. Okay, so we need some kind of function to convert amplitudes into valid probabilities. Okay, a function. So what kind of function do we need to convert amplitudes into valid probabilities? A function where the output always gives positive numbers, and adds up to 1. So what does the adds up to 1 really mean? It means that P of 0 plus P of 1 actually 1. It is just this rule. Okay, so quantum rules says that P of 0 equals modulus alpha square. Okay, so now let me explain what modulus alpha square mean. Suppose if alpha is a normal number, okay, like 0.6, so modulus alpha square would be 0.6 square. But what if alpha is complex? What if alpha is a complex number? So complex number structure looks like this: a plus ib, where a is the real part and b is the imaginary part. I is square root of -1. Okay, so let me help you guys visualize this in a 2D plane, two-dimensional plane. Okay, so this is real axis and this is imaginary axis. Okay, here horizontal is the real part and vertical is the imaginary part. There's a point where it's a and b. This is a, this is b, this is origin, and if I want to find the distance of this point from the origin, I have to use Pythagoras for this. Let's use Pythagoras, which says distance equal to a square plus b square, square root of a square plus b square. Okay, let me explain it more clearly so that you can understand it. First of all, what is the distance? What is distance? Okay, if a point is a and b in a 2D plane, distance from origin 0 is root over of a square plus b square. Okay, this is distance. Okay, that's just Pythagoras. That distance is called magnitude or modulus. Okay, this distance is called magnitude. Okay, or modulus. Okay, so This is how we write this. Modulus z equals root over of a square plus b square. Okay, this is the distance or magnitude. So what is z square? What is z square? If we square both sides, z square would be a square plus b square, because square and square root cancel, and modulus z square equals a square plus b square. Okay, now let me tell you how does z square, modulus z square equals a square plus b square come from z equals a plus ib. Now I am explaining why do we define it like this. Okay, why do we define it like this? As you all know, z equals to a plus ib. Okay, and we have to find the conjugate of it. Okay, z conjugate is a minus ib. So conjugate actually means flipping the sign of the imaginary part. Okay, flipping the sign in front of the imaginary part. So z equals a plus ib, z conjugate equals a minus ib. We just flip the sign in front of the imaginary part. Okay, now let's multiply both. Let's multiply z into z conjugate equals a plus ib multiplied by a minus ib. Okay, now let's expand these. A square minus aib plus aib minus I square b square, and plus minus cancel, then a square minus I square b square remains. So I is square root of -1 or -1. So if we square it, the square and square root cancel, only -1 remains. So a square minus -1 b square. So a square plus b square remains. Okay, so the final result is a square plus b square. We found this by multiplying z with z conjugate. Okay, so now we can write it as modulus z square equals z multiplied by z conjugate equals a square plus b square. As you can see, there is no imaginary part that remains here because it cancelled out earlier. So I hope you understood why imaginary part disappeared, because it cancelled during multiplication. You can see it here. It cancelled with during multiplication. Okay, it's pure algebra. And why this is perfect for probability? Why this is perfect for probability? Why this is perfect for probability? Let me answer you this question. Like, distance squared is always positive. First point here is distance squared is always positive. That means alpha square or modulus alpha square is always positive. Always positive. So it works as probability. Okay, so it works at probability because it always positive. That is why quantum probability is defined as magnitude square. That's why quantum probability is defined as magnitude square. Magnitude squared. I hope you understood it. Now the most important part, interference. Let's discuss it. interference. Now here is the reason amplitude must be complex. The reason amplitudes must be complex. Why amplitude must be complex? It is because quantum system shows interference. Okay, what do I mean by that? Imagine there are two ways something can happen. Okay, imagine there are two ways something can happen. Each way has an amplitude. Okay, way 1 has an amplitude which is 1. Way 2 has an amplitude -1. Okay, now in quantum mechanics we add amplitude first, then square. Okay, then square. Okay, this is what we do. In quantum mechanics we add amplitude first, then square it to find the probability. Okay, to find the probability we square, but first we add amplitude first. Way 1 is plus, way 1 is 1, and way 2 is -1. Way 1 is 1, like way 1's amplitude is 1, way 2 amplitude is -1. Then if we add that, 1 plus -1 equals 0. Then if we square it, it's become 0. So that means the final probability is 0. The final probability is 0. The two contribution cancel. That is interference. Okay, this is interference. Classical couldn't do this. Okay, because we can't have negative numbers. Okay, why we can have negative here? Because these are amplitudes, these are not probabilities yet, these are amplitudes. That's why quantum is powerful. Okay, this is called interference. If amplitude were only real numbers, cancellation could only happen in one direction. Okay, let me tell you why complex makes it richer, more powerful. If amplitudes were only real numbers, if amplitudes were only real numbers, cancellation could only happen in one direction. Cancellation could only happen in one direction. But complex numbers live in two dimension that allow richer pattern of reinforcement and cancellation. So complex numbers allow amplitude to rotate in a plane that make interference more powerful. Okay, I hope you understood this. So let me tell you the final summary, like, so that you can connect everything that we have studied so far. First of all, we need probabilities that are positive and sum to 1. We need probabilities that are positive and sum to 1. Second point, so we define probabilities as magnitude square. So we define probability as magnitude squared. Third point, magnitude squared works even for complex numbers. Magnitude squared works even for complex numbers. So the fourth point, is complex numbers are necessary because quantum systems show interference. Okay, complex number are necessary are necessary because complex numbers are necessary because quantum systems show interference. Quantum systems show interference. Okay, complex numbers are necessary because quantum systems show interference. The fifth point, interference happens when amplitude combine before squaring. Okay, interference happen interference happens when amplitude combine before squaring. Interference happen when amplitudes combine before squaring. Sixth point, and that is the mathematical foundation of quantum behavior. Okay, and that is the mathematical foundation of quantum behavior. These are the 6 point summary. First of all, we need probabilities that are positive and sum to 1. So we define probabilities as magnitude squared. So magnitude squared works even for complex numbers, and complex numbers are necessary because quantum systems show interference. Interference happens when amplitude combine before squaring. Okay, and that is the mathematical foundation of quantum behavior. I hope you understood it. Thanks for watching the video.